All right, we're going to continue on with Excel. The assignment's here in week 7. And essentially what you have to do is create 3 different sheets in the workbook. So when you open Excel, it's actually called a workbook. And then within the workbook, it has sheets. So this is going to be practicing working on different sheets and then combining information in the sheets. So think of each sheet as a piece of paper. And then the last page is going to be like a summary where you'll pull things from other sheets. So that's a little tricky. The notation for it's a little tricky. So it's a good thing to practice. In here, I say that you're going to create these triangles and then we're going to solve the triangles. I want the inputs to be, I think I said green. Let's see, shade those green. Yeah. Oh, output is green. Input is red. So obviously I'll show you some shading techniques, but that's nice for you when you open up the spreadsheet, you know, a year from now to know what areas are areas that you want to input and what areas you want to like just get calculated. So I'm going to swap those. So did I say input green? No, I think I said equations green, right?
Input red, output green.
Yeah. So I had them backwards. Right? So you can just click on a cell and then you can change the shading up here, just pick a color. Does nothing to the input of the cell. It just allows you to kind of keep track of. And it's really nice to know that there's notation on that, right? So input and calculations. So when you come back in, right, you know where calculations will be. They'll be right here, and then inputs are here. So these are just numbers. Remember to separate your numbers from your units, but all numbers need units. So that's 54 inches, that's 40 inches. This is the hypotenuse, or you could call it side C. You can call it whatever you are comfortable with. And then this is the angle for this lower angle here. You know, you can get as tricky as you want, and you can draw little arrows to show like where stuff is. If you want to do that, you can. Totally up to you how tricky you want to get with this. But what we want to do is then be able to calculate all the sides and all the angles of this triangle. So that's going to be using our trigonometry. And then I think I also asked for the perimeter. Okay. So, and all that is done on this sheet. So you'll see down in the lower left, it says sheet 1, right? And you can change that. You can right click on it and rename, and it could be triangle 1, right? And then you can add sheets. So if you go plus, you can get another sheet, right? And this would be rename triangle 2. So it's just like a clean piece of paper. You can copy, like if that's the triangle I wanted to use, you can copy it if you didn't want to create a new one. And you can copy equations from sheet to sheet. And then you can also access data and summarize stuff from sheet 1, sheet 2, and sheet 3 onto sheet 4. And that's what the exercise is, to do all that. Okay. So let's just muck our way through a little trigonometry here. If I wanted to know the hypotenuse, let's brush up on our trigonometry. How could I get it? Yeah, what's that called? Yeah, Pythagorean theorem. So let's see if my visualizer's gone. Well, that sucks. Really? I'm determined to say it's not gone. Oh, maybe it was gone. No, it's pretty gone. About this one. Oh, there it is. Now, why doesn't it show up? Bear with me here. Stop share, new share. There it is. Share. All right. So I heard C squared equals A squared plus B squared. That's Pythagorean theorem, right? So if you know two sides, you can get the third side with that equation. How else could we get it? Sine of the angle equals opposite over hypotenuse. So if I know an angle, I can use opposite and hypotenuse, right? I have to know the opposite to find the hypotenuse. So I could use sine to solve. So either one works. Use either one, whatever, however you set your triangle up, you can only give yourself 3 things of the triangle. So I've only given myself 2 sides and an angle, right? And then the quest is to find the rest of the pieces with Excel. So that's what we're doing. So you could use either one of these. What was cosine? Cosine, the angle is adjacent over hypotenuse, right? So could we use that one? Yeah, because we know the adjacent and we know the angle. And what was tangent? Oops, sorry. I was writing the number. Opposite over adjacent. Could we use that to find the hypotenuse? Is hypotenuse in this equation? No, so we couldn't use it. I mean, we could use it to find other stuff and then work our way towards the hypotenuse, right? But those are our kind of our units, our equations for right triangles. Remember, this is just right tries. If you give yourself a non-right, then you got to go into what? Yeah, old trigonometry is a little rusty, right? Yeah, so if it's a non-right triangle, something like that, then it's going to be, see if this brings any memories back. Sine law, cosine law. Remember those? Those are a good time, right? Remember, you have to have your angles labeled. I always put C across from, and that's a little c, and that's a little a, and that's a little b, right? So these are the angles, these are the sides, right? And you got to have it labeled or else none of it makes sense. So now I can say, oh, it's a, that side over what? The sine of a. So the sine law sets up just like that 3 times. B sine of B, and these are the angles, these are the sides. And I make my C with the tail. Sine law, okay? Again, you use 2 pieces of it at a time. So I can use those 2, I can use those 2, or I could use the 2 outer ones. If you never use all 3, it'll get like too many variables, right? But again, you got to know 3 of the 4 things. So if I'm going to use these 2, I would have to know 3 of these variables, and I could find the 4th. Okay, so that's the sine law. And then the cosine law was a little bit longer. C squared, that's a side, equals a squared plus b squared. Anyone remember this? Minus 2ab cosine c. That brings back some good memories, I'm sure. The thing is, if you don't use calculus to solve engineering problems, you flip and use trigonometry, and you use it a lot. So in the 2-year program, we are going to live and die by it. So there's the cosine law. And again, of course, you have to know there's 1, 2, 3, 4 variables. You've got to know 3 of them to solve for anything. So sometimes this applies depending on what you know, and sometimes this applies depending on what you know in a non-right. I didn't ask you to do a non-right, but if you want to brush the cobwebs off and make that second triangle or third triangle non-right, you can do that. All right, let's go back to Excel and see how to put it in. I'm just going to stop the share and then a new share. All right, so here is the 30 degrees. We want to know the hypotenuse. Let's build the Pythagorean one, which is the c squared equals a squared plus b squared. So it looks like I got to take that, square it, add it together, and then take the square root, right? So you can try to just muck your way through that equation like it's a calculator, or you can go up and look for equations. I just kind of go for it. I'm like, okay, and I do it in pieces, and then I use my calculator to check as I go through to make sure it's doing it right. So setting these up is time consuming. It's not fast. And once it's set up, then it's fast. You can just use it over and over and over. All right. So let's say, and notice I started with an equal sign. You've got to start with an equal sign. I'm going to just go SQ and stop and then look at what it gives me. So it gives me square root. It's not giving me square, right? And I want to square something. So if I want to put this number in there, I want to go to the power of 2. I'm going to try this other thing, which is a caret. Right? And the caret is above the 6. And I'm going to see what it does. I don't know. Is that the square root of 54? Beats me. So I get my calculator out. 54 squared. Oops, calculator failure. What? Okay, there we go. 54 squared. 2916? Yeah, perfect. So the caret works for squaring things. So I'll click back on it and I'll look up and I see the formula. So that squared that number. And now I'm going to add to it. I'm not going to use brackets. So I don't know how it's going to act, whether it's going to add to the 2 or whether it's going to work when I go to square this other one, this one. Caret 2. So now I'm going to check, right? So it got bigger, that's good. So I'm going to square the 40. That's 1600 and I'm at it 4516. So it's doing the right thing. So the point is use your calculator to check. Don't just assume Excel's got it right because your notation or syntax could be wrong. So now I have that squared plus that squared, and I want to do what? Square root. Yeah, so that did show up when I typed in SQ. Notice I went to the front because I'm guessing I'm going to have to put brackets around it, right? So the notation is SQRT. If you don't double click on it, it's not going to give it to you. Like it's not, I just typed in SQ. It's not, that's not going to work. So I 2-click, it puts the first bracket in, but you got to put the second bracket in. Does it make sense? So then hopefully it does it. And again, I'll use my calculator to do the square root. 67,201. Boom, working. Cool. That's what we want to do. We got to do it for this angle. And this angle's 90. You can note that if you want. You don't have to calculate that because we are doing right triangles. You might note somewhere it's a right triangle, right? But let's do an angle. Let's do this angle up here. I'll call it angle A. For some reason I don't want it over there. So I'm going to write justified. I want it over there. And maybe I'll say, you know, in the alpha area, you can put anything, right? So angle A. And maybe I'll write equals. So, whoops, equals. Something like that. So now I need the equation here for angle A. How do you want to get it? Like we know a lot about the triangle, so we can do anything pretty much. Yeah, sine, cosine, tangent. I'd use sine for some reason. That's just something I use a lot of. So sine is going to be opposite over hypotenuse, right? So it's going to be what? The sine of the angle. So this is important. And I strongly recommend, hope that works. Yep. Strongly recommend you write these things out before you input them, because the sine of the angle is what? Opposite over hypotenuse. But I want the angle, correct? Yeah, so what do I have to do? How do we clear that variable to get it all by itself? Because I don't want sine of the angle, I want the angle. Yeah, so the long notation is, oh, well, I divide by sine, right? And that goes away, so that means I divide by sine. Well, that's the same as what Kyle said, which is sine to the -1, or the inverse sine. So it's going to be theta equals sine to the -1 Geez, it seems so simple when we're not like thinking about it too much, right? But that's how we get the angle. Okay, so remember that. We need sine to the -1 opposite over hypotenuse. Oh boy, so we got to put that into Excel somehow. So I would probably say sine. So then I don't know what sine h is. Let's look. Returns the hyperbolic sine of a number. I don't know what that is. Returns the arc sine of the number in radians. Yeah, I think arc sine is what we want. Yeah. So here's the catch. Excel thinks in radians. Yeah. So when I put 30 here, Excel thinks it thinks it's radians. So everything has to be converted. So here's an example. I did this one just because I have to remember how to do this stuff. So the sine of 30, that's an easy one. That should be a half, right? But if I go sine, oops, equals sine, and then duplicate it, and then put in the 30, and then bracket, that should be a half. It's not, because good old Excel thinks in radians. So the way to fix it is to say radians inside here. And then you'll need an extra bracket. So see what it does? Radians of that number and then sine gives me a half. Yeah. So essentially you're telling Excel, hey, that's radians, flip it to degrees, and then do the sine, but it's got to be inside the sine bracket.
So radians converts a number away from radians. So
It doesn't. Yeah, figure that one out. So look at this. Here, I'll show you. Converts degrees to radians is what it says. So there's another one, right? Degrees, what's it do? So you would think you would use that one. No worky. So it's crazy. Here, let's try it though. EEG, I'll do, equals degrees, and I'll put in this. And then, yeah, see what it does? It's like, what? So this is exactly what we just did, but I'm using the degrees thing instead, and look what it gives you.
So
Garbage.
just to clarify, plainly, radian in equation is a command that converts to degrees.
Radians. So I think what it's doing is it's just telling Excel that this number is radians because Excel thinks in radians, and flip it to degrees, and you will get the right number. Now, if you look at the little description, that doesn't make sense with the description because it says, what it says is it's changing that number to radians. So I don't know if changing a radian to a radian turns it to a degree, right? Like some kind of double multiplier. I don't know, but let me tell you, that's the only way you're going to get the number. And again, back it up with your calculator, right? All right, so let's do some more testing here. What is the inverse of the number we want, which is what? Opposite is 54. I'm just testing here. And 67.201. And then inverse arc sine is what we want. So that should be 53. All right. Did I get the arc sine? Wait, I got something screwed up. Scratch that. Can't do simple division right now. Opposite over hypotenuse 54. I'm just going to use basic numbers 67 divide arc sine We're looking at for 53, basically. So for this angle up here, 53 degrees, right? All right, so let's try the arcsine thing. And it should be arcsine of opposite, which is the 40, right? Oh, so my number's off. I did this one over here. And then divided by what? Yep. Right? According to my formula, that should be the right number. Opposite over hypotenuse. Since we're going for this angle, this is opposite, this is hypotenuse. Yeah. Not great. Sure, it's not that angle, right? So that means what? It's got this radian problem. So I think it's got to be inside here. Am I inside? Nope. Radians. I'm just going to plop the bracket in and then this other bracket there. That didn't work.
Does it have to be before A sign?
It must have to be here. It's got to be inside the A sign. So let's try it out there. And then we'll try it outside if that doesn't work. Entirely too many brackets. 3 and 2. Yeah, I do, but it's all right. No work.
Threes, field values?
I hope not. That's going to be a problem. It's getting rid of some of these brackets that are confusing. So that does not give us the right number. Let's just convert the whole thing.
It would make more sense if it was the conversion and then the equation, right? Like you call it, basic code.
What? I get 53. 40, 67 divide arcsine. Nope, 36. Wow. So in this case, degrees does the correct conversion. And in this case, wow.
That's what.
It's not really fun. Yeah. Crazy. All right, well, it's one or the other, and outside is the way to go. So there'll be some trial and error for you, and that calculator will be critical. All right. That's probably enough of that. You can muck your way through. I'll talk about just multiple sheets now and how to get information from one sheet to the other. So I'm going to add another sheet, and then sheet 4 is going to be, I'll call it summary. And I didn't ask you to do much. You can do more if you want, and you can move these around. That's kind of fun. So I'll put summary at the end. Triangle 2 will be here, and then that would end up to be triangle 3, right? So that's cool. So I might write triangle 1 and I don't know, maybe perimeter. So I'd put the perimeter right here of triangle 1, right? Just building a little table. You can do it however you want. So now I'm going to go back to triangle 1 and I'm going to give myself the perimeter real quick. I'm like totally not spelling there. That look better? That looks better. All right, what is the perimeter? All that plus that plus that, correct?
What's the markup shortcut again? Or just tagging a box?
Just picking it? Is that what you mean?
Yeah.
Yeah. So like this, I just picked these boxes.
Right.
I didn't type them in.
Yeah, but then what's the hotkey for this?
None. Yeah, so if you're at equals, right, if you take in equals and then you pick a box, it's gonna throw in that cell. Yeah, it just does it on its own. Yeah, guess you can't see my fingers, can you? That makes sense. Good question, thanks. All right, so there's the perimeter. So that's the number I want on sheet 4, right? Control C, that's a copy. Move here, place it, Control V. So that brings in the equation. It did not bring in the dang cell. Why? That's different. There it is. I guess it's paste options now. That's cool. Yeah, value right there. So that brings in the value. All right, let me do this again. I bet it works with Control C also. Control C. Better because, and then paste option, the second one is the value. So yeah, that just brings the number in. If you want to bring the equation in, I bet one of those paste options will actually bring the sheet equation in. So I want to see if that's true. There it is. Nope.
It might just be the default paste.
You can bring in. Oh, I lost my copy. Lost my copy. Going back. That's interesting. That's different too. Yeah, you used to be able to bring in the equation from a sheet. And what it would look like was sheet 1. Returns sheet number of referenced sheet. No, that's not what I'm looking for. Returns a number of sheets in reference. Nope, maybe they don't do it that way anymore. All right, well, that works. That brings a number in. Let's just verify that. It's like they simplified the syntax. What if I change a number? 50, right? That changes my perimeter. So that's why that's how we want it to work, right? Change one thing on the inputs, the red, can't change it here. That's an equation, right? And that's an equation. So that should be reflected here. It's not doing it. It's not tagged to that sheet.
Is there a way to like tether one grid square to another?
Yeah.
So what results on sheet 1?
Yeah, that's what I'm freaking trying to do.
It's still the same document.
Oh, sorry. I am slow today. I know how to do it now. Equals, gotta have the equal sign, then travel, then pick it, and then hit enter. See how it comes in? But look how it's tagged to that triangle and that cell. So let's do it again. I want it to be an equation, not a value, right? So it's got to be equals. That says, okay, now this is going to be an equation, and you can literally just go click on that and hit enter. And it comes in. So now when things change back to 54, go to the summary there. There it is, changed. 161 matches 161. That's an equation that should be red. Change another number. I'll go to 45 on the base. That gives me 69 for the perimeter, right? Go to the summary, 169. That's working. So there's the notation, but it's more complicated than I ever want to remember. So I try to do it the other way. So that's the way we want it to work. Good. I'm glad that's recorded. We finally got to it. All right, that's it. So you're gonna do that. You're gonna do a triangle here. Again, solve it all out. You can use these formulas once you get them working. Just drag them over just like I did that formula, right? So if I wanted that in a different triangle over here, I'll just show that real quick again, since I kind of mucked it up. So make your triangles a little different, like, okay, this one's a little different. It's like short and squatty. But to get that angle, right, if I knew these two sides, I could use this equation, right? But I'd have to know these two sides for this to work. Does that make sense? So to use it, I come over here, I hit equals, I come over here and I grab the equation and it pulls it in, right? So it's using the values from the other triangle. So you'd have to set this up and then modify this. So might be more trouble than it's worth. It might be easier just to create those equations from the beginning. All right, I think you got it. I think we made it as clear as mud, so that's good.